Welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? Warm-up 31 is on the screen. Do me a favor, copy the whole thing first, because we're going to move on pretty quick. Today's the minimum day. Just giving you a heads up. Stay focused. Give you guys 1 minute. Copy the whole thing, please. Go. All right, here we go. Like I said, today's minimum day is going to go pretty quick, so stay focused. Here it goes. Number one. For number one, we have an absolute value, and we said the first thing to look for is to see if it's a negative or equal to a negative, since absolute values cannot be a negative. No, in this case, we have a positive. Second thing to look for is the absolute value by itself on one side, yes. So at this point, we make two equations. One for negative 8 and one for positive 8. One for negative 8, one for positive 8. Positive 8, negative 8. So which is the number that we make a positive and a negative? The number by itself. Are we there so far? All right, so with that, we're going to make two equations. Where do we get the rest of the information, Mr. Q? Whatever's inside the absolute value. So we write x plus 2, x plus 2. And now we have two equations. So now we just solve. Here we go. Minus 2 minus 2, x equals negative 10. Minus 2 minus 2, x equals 6. All right, did we solve? Yes. Next, it says to graph. Here it goes. Here's your number line. 0, 1, 2, 3, 4, 5, 6. 1, negative 1, dot, 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 negative 10. So how do we plot our solutions? 6 and negative 10. And that's it. That's how we graph absolute value equation solutions. Am I done? No, it says write the solution set. For absolute values, this is what you write. Solution set. My first value is negative 10, comma. What's the other value? 6. And you close your solution set. That's how you write solution sets for absolute values. Number 2, factor. All right. Very similar to the one we did yesterday. Is there a GCF or anything that divides all three terms? No. So, what is 5 times 2? 5 times 2 is 10. Next, 11 goes down here. What two numbers multiplied give me 10 that when you add them give us 11? What are they? 1 times 10? 1 times 10. 1 times 10 is 10. 1 plus 10 is 11. That is correct. However, now we have the 5 in the front, so what do we do with that? We put it on top of the 1 and on top of the 10. So question, can we simplify 5 over 1 anymore? No, so my factor is 5x plus 1. Can we simplify 5 over 10 anymore? It's the simplest terms. Yeah, divide by 5 top and bottom, right? 1 over 2, is that correct? So this would be x plus 2. So the top numbers always are x, the bottom numbers always are constants. And these are my factors. Number 3, inverse. Bless you. Let me make some space here. Here we go. So we got y equals 3x plus 2 minus 2 minus 2. Y minus 2 equals 3x. Divide by 3. Y minus 2 over 3 equals x. Exchange the variables. So we end up with x minus 2 over 3 equals y, or x minus 2 over 3 equals f inverse of x. Next, y equals 5x cubed, divide by 5. Y over 5 equals x cubed. How do we cancel that cube? We do a cube root. So cube root of y over 5 equals x. This cancels that. Exchange the variables. So we end up with cube root of x over 5 equals y, and in function notation, x over 5 cube root equals f inverse of x. Pretty good, yeah? Pretty good? Oh yeah, we love these. All right, number 4. Once again, I'm going a little bit faster because today's minimum date, we only have about half an hour instead of having our full 50-some minutes. Okay. All right, number 4 says graph f of x equals x squared. So let me get a coordinate plane going over here. All right. So your neighbor, the 5 points for f of x equals x squared, please. All right, looks like Autumn's got it. Natalia's got it. Diana's got it. Let's go with Gloria. What are our 5 points for f of x equals x squared? Negative 1, 1, 0. What else? 1, 1. 2, 4, and negative 2, 4. That is correct. So those are my original 5 points, f of x. However, they want this transformation, so I write g of x equals a times f, x minus h plus k. Whoop. Or g of x equals blank times f, x minus blank squared plus blank. So what values do we use? We use a is negative 2, h is negative 3, and k is negative 7. So if I rewrite that, my new transformation is g of x equals negative 2 f x, negative times a negative is a positive 3 squared, and negative times a positive is negative 7. So tell your neighbor, where are we going to move those points at the end? Where are we going to move those points at the end? All right. Where do we move those points at the end? Scarlet! Down. And to the left. Hands if you agree with that? Yeah. However, before we do that, with red, should circle this part. What does this 2 do to each of these points? Well, let's see. Instead of negative 2, 4, it should be negative 2, what? 8. However, if it's a negative, it's going to be negative 2, negative 8. Down here at negative 8. Next one, negative 2, 1. Instead of negative 2, 1, it should be negative 2, 2. But since it's a negative, negative 1, negative 2 at negative 2. 0, 0. The other ones just reflect. So here are my 5 new points, and now we can move them what? 3 to the left, 7 down, 3 to the left, 7 down. So they're going to be somewhere down there, stretched and upside down. Tell your neighbor why it became an upside down function. Tell your neighbor, why did that become an upside down function? Everyone, why did that become an upside down function? Because of the negative. That is correct. Last but not least, number 5, simplify. So what is GCF for these 2 terms on the numerator? it can be divided by 3 and 1x. Is that correct? So that would be 3x, and that leaves us with x plus 2. So that is our numerator. Let's go to the denominator. What is our GCF for the denominator, everyone? 3x as well. That is correct. So 6x squared divided by 3x is, 2x. Because 2 times 3 is 6. 2x. And then negative 9 divided by 3x is negative 3. Last but not least, do you guys see a giant 1? Yes, Mr. Q, because 3x is multiplying there and multiplying there. So my giant 1 is the 3x. We get rid of it. So what do we have left? We have left x plus 2 over 2x minus 3. And that is simplified. All right. All right, copy the agenda, please. Warm-up 31 done. We're in the middle of radical functions. Tonight's home plate, numbers 1 through 20, evens only. But then I forgot that we had minimum day. You guys can do 20, can't you? Cue from the corner. Let's go. No, let's do evens only. Is that even? Yes? Once again, warm-up 31 done. Radical functions, numbers 1 through 20, evens only. All right. Copy this code to access the home play. GS2TQ. 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 All right, do me a favor, get a Cornell note ready, please. It's going to go super fast, and also you need at least one graph paper. So they're back here, send a gopher or a neighbor. Give you guys a little bit of time to set up. All right, here we go. So once again, yesterday was Act Like Tomatoes. I gave you guys the afternoon to make sure you had all your assignments turned in, especially those of you that are missing assignments. Thank you, Mr. Q. You're welcome. I got you. Yes? All right. So, tonight's home plate looks like this. Ha, ha, ha. Ah, ha, 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 ha. Ah, ha, 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 ha. But only evens. All right? Here we go. I can solve and graph radical functions. Write that down. I can solve and graph radical functions. I can solve and graph radical functions. And once again, if you were to tell your neighbor what is the main concept that we're working on, tell your neighbor what is the main concept we're working on. Yeah, radical functions, radical functions. Now, back in the 80s and 90s, we used to use the word radical because there was a cartoon that was going on that they used that word, radical, dude. And it was all the Teenage Mutant Ninja Turtles when they first came out. They were all into like surfing and skating and skateboarding and so on and so forth. So, we know what radical functions are, is that correct? And what they look like. There they are, there they're not. Yesterday we started with our general rule. We did graphing the parent function, then we did the transformation, is that correct? Then we did another one, and then another one, but then we solved it. We graphed it and solved it, yes? All right. So, before I move on, look up. Tell your neighbor where we're going to move this function to. Where are we moving that function to? Where are we moving that one to? Don't copy it. Just tell your neighbor where we're moving it to. All right. Let's go with Maria. Where are we moving that one to? 7 to the left and 9 down. Hands, do you agree with that? That is correct. Now, just to recap, we start off by graphing f of x equals square root of x. Don't copy this. Remind your neighbor of the 3 points that we used for this one. Tell your neighbor the 3 points we used for that one. 0, 0. What else? 1, 1, and 4, 2. We always start with those 3 and then the transformation. Okay. However, I wanted to address this one. Writing utensils down, look up to the screen. Look up, please. I start off by graphing my parent function, which is f of x equals square root of x. Yes? 0, 0. Pay attention to this part. You're going to miss it. 1, 1, 4, 2. Now, if I was to ask you to transform it according to this, tell your neighbor where we're going to move it to. Tell your neighbor. You're like, wait a minute, Mr. Q. Isn't this one different in the inside? Yes, it is different. So, we know it's moving 16 in what direction? Down. And then your brain wants to say 8 to the right, which is incorrect. Why, Mr. Q? Because now the x has a number in front of it. So what do we do with that, Mr. Q? We set it equal to 0 and solve. Plus 8 plus 8. 2x equals 8. Divide by 2, divide by 2. X equals what? So that means instead of moving it 8 to the right, we're going to move it what? 4 to the right. You're already following that. All right, once again, I said don't copy this. I'm just elaborating on this. All right, explain to your neighbor one more time. Tell them why that one's different from this one. Why is this one different from that one? Talk it over to your neighbor. Why is that one different? All right, help us out. Carlos, why is that one different? It has more numbers inside, specifically in front of x. There's a number in front of x. Whenever you see a number in front of x, set whatever's inside equal to 0 and solve for x, and that's going to be your steps that you're going to take. All right, enough of that stuff. Yesterday we did this one before we left. Is that correct? All right, copy this one. Example 2Q. Write that down on your paper. This one on your notes, not on the graph paper. Parentheses, x plus 5 to the 1/2 minus 2 equals 2, 1. It says solve and check. Okay. All right, let's do this one together. Everyone, what is this? It becomes what? Square root. That is correct. So bring down the x plus 5 inside. Then outside we have the negative 2 equals 1. So we need to leave the radical by itself. So what do we do, everyone? Add 2, add 2. So we have square root of x plus 5 equals 3. How do we cancel that square root, everyone? Square it. Squared both sides. Cancel, cancel. X plus 5 equals 3 squared, which is 9. And last but not least, solve for x. We what? Subtract 5, subtract 5. X equals 4. All right, I'm going to put a big check mark on the right over here, and then we're going to check it. So parentheses plus 5 to the 1/2 minus 2 equals 1. But instead of x, we're going to substitute what value? 4. So what is 4 plus 5? 9 to the 1/2 minus 2 equals 1. And again, what is this again? Square root of 9 minus 2 equals 1. What is square root of 9? 3 minus 2 equals 1. Is that correct? Yes. And fuego. I like these. I like these for tonight, right? You can gather all your family together. Gather around. Let's make it a family math night. Look what I learned. You'll be the popular one. Let's go to the next one. Copy example 2 mega cube. Solve and check your answer. 2 plus square root of x plus 10 equals x. 2 plus square root of x plus 10 equals x. Now this one's going to require some work, so stay focused, please. All right, here we go. We need to leave the square root by itself, so what do? No, not yet. It's not by itself yet. Minus 2 minus 2. So we end up with square root of x plus 10 equals x minus 2. Now we cancel the squared. How do we do that? By squaring it. But the other side has now more numbers, so we put them in parentheses to square them. This cancels that. We're left with x plus 10 equals x minus 2 squared. So look up. I'm going to do the work for this over here on the side. X minus 2 squared is x minus 2 times x minus 2. You guys remember that? Yeah? Very good. X times x is x squared. X times negative 2 is negative 2x. Next, negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. Can we combine stuff? Yes, these right here. So then we end up with x squared, negative 2 and negative 2, that's negative 4x plus 4. This looks a little familiar because now we have a quadratic equation, so we need to get rid of the left side, so we subtract x and subtract 10. Subtract x, subtract 10 from each side. 0 equals x squared, negative 4x and minus x, that's negative 5x. Then we got negative 10 plus 4, that's negative 6. So, how do we solve this? Tell your neighbor, what do we do next right here? So we go negative 6 on top, negative 5 underneath. What two numbers multiply give me negative 6 that when you add them give us negative 5? Talk to your neighbor. What two numbers multiply give us negative 6 and when you add them give us negative 5? All right. Let's go with Jaime. What two numbers? Negative 6 and positive 1. Negative 6 times positive 1 is negative 6. Negative 6 plus positive 1 is negative 5, yes? So, we break up the x squared into x and x. Write the negative 6 and the positive 1 equal to 0. Set each one equal to 0. X minus 6 equal to 0. X plus 1 equal to 0. Plus 6 plus 6. X equals 6. Minus 1, x equals negative 1. All right, let's check it. I'm going to write the original one, this one over here, twice. 2 plus square root blank plus 10 equals blank for x. I'm going to need more space here. 2 plus square root plus 10 equals blank. So my first value that I'm going to substitute is 6. So let me break it down. 2 plus, what is 6 plus 10? That's 16 equals 6. Question, what is square root of 16? 4. Is 2 plus 4 equals 6? Yes. Next value, negative 1, negative 1, negative 1. So, 2 plus, what is negative 1 plus 10? What is it? 9 equals negative 1. Did I make a mistake? I think so, right? Let's double check. So then we got square root of 9 is 3. So 2 plus 3 equals negative 1. Is that correct? No. What did I do? Where at? let's see, minus 1, x negative 1, negative 1. I don't see it unless I do a negative root here, but I'm going to leave it right there. So we're only going to use, for right now, the positive 6. All right, let's go to the next one, please. Copy this one, example number 3. Square root of x minus 2 over 3 equals 2. Copy that. All right, here we go. We need to leave the radical by itself. What do, everyone? It's dividing by 3, so we need to multiply times 3 both sides to get rid of that 3. So we're left with square root of x minus 2 equals 2 times 3 is 6. What do I do next to get rid of that square root, everyone? Square to both sides, so this cancels that. X minus 2 equals 6 squared, which is 36. And last but not least, plus 2, x equals 38. And by now we know how to check, so I'm not going to do that so that we can save some time and go to the next one. From 1 to 5, what can provide you with these? Where are we at? 5 4s, 2s, okay, 5 4s, 3, 6. Do this one by yourself. Example 3q. Negative 3 square root of x plus 5 over 4 equals 3. Very similar to the one we just did. Similar. I'll give you a head start. Go. All right, check with the neighbors, see where they're at, and then Julian's going to get us started. All right, Julian, what do I do? Multiply times 4. We end up with negative 3. Square root of x plus 5 equals 12. Then what do I do? Very good. You divide by negative 3. Divide by negative 3. That leaves us with square root of x plus 5 equals negative 4. What to do next, Julian? Square it. Square it. X plus 5 equals 16. And last but not least, everyone, minus 5, x equals 11. Woo-wee. From 1 to 5, I'll compare you with this so far. Where are we at? Let's see. 5, 5, 4, 3s. Okay, 3s, couple 3s. All right, we need more practice. All right. Copy this one onto your graph, please. This is going to be our last one. Example 4q. It says graph g of x equals 2 square root x plus 5 plus 4. G of x equals 2 x plus 5 square root, and then outside the square root plus 4. So by now, we should know that we need to start graphing the parent function. Is that correct? So first, I write f of x equals square root of x. Tell you never the 3 points we're going to use for that. 3 points. Miguel, 3 points. Zero, 0. 1, 1. 4, 2. All right, thank you. And Miguel's on the ball. He was like, I'm ready, Q, without hesitation. However, look up. They want us to transform it according to this. Tell your neighbor where we're going to move that to. All right, Gio, before I take away your phone, where should I move that to? To the left, and then up 4. Okay, 5. And by the way, this is being recorded. So, Gio, you said 5 to the left, 4 up. Okay, however, before we do that, people, circle the 2 in red, what does that do to these points? Talk about your neighbor. What does that do to these points before we move them? 0, 0 stays the same, but where do we move 1, 1 to? 1 what? 1, 2. That is correct. How about 4, 2? Where does that move to? 4, 4. That is correct. So plot those points. So now we have 3 red points that we're going to move 5 to the left and 4 up. 5 to the left, 4 up. 5 to the left, 1, 2, 3, 4, 5. 1, 2, 3, 4. This one, 1, 2, 3, 4, 5. 1, 2, 3, 4. And this is our g of x. From 1 to 5, I'll come through these transformations now. Where are we at? 2s, 5s, 3s, okay. Once again, we've been doing transformations, and I'm assuming you've been doing your own practice with the transformations. Today, the only thing I added was the a, that 2, which is multiplying that value up or down. I'm going to stop right there. Once again, practice your home play. Today's minimum day. You can go out and play. By the way, tell everybody, hey. Anyways, those of you following on YouTube, put in some practice. See you guys next time. Peace.